Okay.
So that I can use this last time. I use this, upload it somewhere. What am I doing? This guy has to share screen. Okay, cool. So I think so. We have been working. Let me share screen on this first. Which one is this? This one. So yeah, so DP, we have kind of seen a lot of these problems already. I want to finish DP and go into these other minor things which we left out. And last week, we were looking at some random problems that was asked to me in Qualcomm. But so anyway, what you've seen in DP so far is we started with this memoization and what is memoization, what is recursion, what are these overlapping problems, etc. Then we went on to the stairs problem, I think. Oh no, gold mine problem. Then we even looked at the stairs problem in between. But in between all that, there was one thing which was missed, which is known as the coin exchange problem. And okay, there is edit distance also. I probably might not go there. But one thing is this coin change. It's a standard problem which has a lot of utilities in so many different places. Okay, so let me switch screens again. Time share content. Perfect. Okay, so you can see this whiteboard now.
Yes.
So what are the date today? It is
29th.
29 May 24. Okay, let's call it coin change. Question is actually very simple. So which is, given a set of coins, let's say denominations, right? TEN, and you're given like $1, $2, $3, whatever, 5, 10, 20, 50, 100, 200, 500. So your goal is, given a value n, let's say n is equal to 2, 4, 4, 5. Your goal is to find a minimum number of dollar bills required to get to 2445, and B, assume you can use a given coin multiple times. So that is also your option. But even before all that, if I ask you, just forget this part for a second. If I just give you this problem alone, which is, here are a bunch of coins or dollar bills. And if I, like, forget computer science also, if I am as a human being, if I give you these and ask you to get me 2445, what would your first intuition be?
To be greedy and find the maximum, take the biggest denomination and go from there.
Correct. So you will try to do it maximum with maybe 500 times 4, get it to like 2K, right? And then you'll probably do another 200 times 2. That's another 400. Then you have 40 and 5. So you will do, let's say, 20 cross 2 and 5 cross 1. So that is 40 and 5. So this will become 2445. Okay. So you should always remember, like, in the world of DP, dynamic programming, there is always a greedy solution possible. But greedy is not really a solution. It's just an approach which humans are good at because we are greedy. But the problem with using greedy is it can generate infinite amount of problems, like amounts of problems can be generated with greedy approach. On the other hand, dynamic programming, if you straightforward use the 4 techniques we created, so this, what happens to people is, when people hear greedy question, they think it's, oh, sure, it's easy, right? And they will start attempting it as greedy, but then they soon realize this particular greedy problem has a tough nuance to it. And there are way too many problems, right? Too many problems, too many permutations and combinations of problems. Dynamic programming, the moment people hear that, they say, oh my God, it's a hard problem, I'm not going to touch it. But the truth is, there is exactly one solution for dynamic programming. I know we haven't seen it yet. We haven't seen that level of abstraction yet. So what so far we saw were like stairs, then 2D grid, gold mine, and then we did backtracking on that. What else did we do? Yeah, I think that's all we did, right? Dynamic programming, yeah, take it. But point is, dynamic programming should be the one you should be really happy about if you get it in an interview, because interviewers think it's a hard problem, but really there's only one solution. Any number of dynamic programming problems, there's exactly one solution, which one solution will fit for all of this. So it's actually in your favor that if you get a dynamic programming problem, and a part of the solution we already saw, which was, let's start, do you remember these multiple steps which we are adding to get DP?
Yes. One is, of course, we come from iterative solution. Are you talking about that? Like first we tried iterative, then we tried recursive, and then we add memoization into it.
Right. So there's brute force / iterative, right? Then we do what? Recursion. Okay. Then you add then plus data structure becomes memoization, and then you take away the thingy. You just add plus iteration, and that becomes your DP, because it's simply because the recursion is never a solution, it's only a starting point. Okay, so we saw part of this solution methodology. Now let's look at what is this one single size that fits all. Now let's do this again. So if I get this guy, denominator, please work. Copy. Okay, perfect. Touch this. What the hold इसने time पे I would have written this down myself and got me again. Okay, let's rewrite it. So let's say if your gold number is $2445, and also remember, greedy is an approach which is really like, given a question, here is an answer. But dynamic programming, by definition, is an optimization solution, right? There are so many different paths, and you have to find the best path out of it. So which is why DP is interesting and hard initially. So because of which this is an optimization problem. So greedy will give you a solution, but almost never will be the right solution. So let's start with the same problem. Let's start with our recursive solution. So let me rewrite the problem again. Your denominations are 1, 2, 3, 5, 10, 20, 50, 100, 50, 100, 200, 500. Okay. So before that, let me see if you remember our major steps in problem solving. What was the step 1? Any given problem?
Paraphrase.
Okay, paraphrase, good. What is step 2? I wrote it correctly.
Core logic.
That we'll get to in a second. Let's say in the core logic, let's say we are using recursion. What are steps in recursion?
A function signature.
Okay. Then?
Me, my.
Me, my children. What can I do? Okay, what else?
Exit condition, base case or exit? I'm confused which one comes first.
Okay, base case. And what is the next one?
A parting gift.
Parting gift. Okay. Okay. So, and इसमें what else is left after core logic you write on paper?
Code it. It will not dry run it.
Okay, dry run. Okay.
Code it. Okay.
Online editor. Anything else? So I can tell you the last step is click run, but there's one step missing after code it, and at least one step missing.
Optimization.
For what?
No. Complexity.
Yeah, that and all you'll figure out on the way. We don't explicitly do that during the solution, right?
Try run. No, I don't remember.
Yeah, so one was edge and null cases, right? We almost never do that because we just try to get it to run, but that's okay. Just have this in mind. And second thing is read out loud, because when you read, you get a lot of syntax error. The goal is by the time you click run, you must be 100% sure there is no mistake, neither in the logic nor in syntax. Okay, so just reminding you all the things which we have been seeing since almost 3 or 4 months ago. Okay, so let's get back to the problem of denominations. Now, we understood the problem, right? Okay, given all these coins, how can we get to 2, 4, 4, 5? Okay, so your paraphrasing part is done. Okay, so now core logic. Let's start with recursion. Tell me, what would you write a function for this? What would be the function signature for this? Like what you, okay, tell me what is the question here?
Given an amount, I have to tell the minimum number of coins that I will use from the list of denominations given. So I have to tell the minimum number of coins that I will use. And I can repeat those coins. For example, I can use n number of 500 denominations.
Okay, actually for now, let's just forget the repeat part. Assume you can only use everything only once.
Okay, so given an amount, we have to tell the minimum number of coins that will be used in order to, that will sum up the total amount given, and you can only use one coin once.
Right, okay. Fine. So then let's say, what will your function signature be?
So we will return an int. Color is too light.
Let's say public static. Again, remember, we just write in Java, but code in Python, that's okay. Public static, you want to return an int, which is the minimum number of ways. Okay. Let's say min ways is the name of your function. What is...
You take the total amount.
Okay, so you have an int total.
And we have an array of denominations.
So int array denominations. Okay. Okay. So that's good. So what we are doing here is in this step, we wrote function signature. Now comes the interesting part. So now, if you remember, so I always go back to the Fibonacci, right? Fibonacci is, we just have indexes 0, 1, 2, 3, 4, and we have 0, 1, 1 plus 0, 1, 1 plus 1, 2, 2 plus 1, 3. Where is the parent and where is the child? Like, who parent is the one who is asking the question, which is, let's say, give me the 4th Fibonacci number. In the screen in front of you, does parent sit in the right-hand side or left-hand side of the picture?
Right side.
Okay, so parent is the one who is asking the question. Okay, so give example is, give me 4 fib of 4, the 4th Fibonacci number, or even like it's a factorial, 4 factorial. Okay, and this is your child, but where are you sitting?
I'm on the left.
No, you're a child. You're not a child. So I'm saying you as a person, remember we would say you are sitting, you know, and all you do is look at my children. They are telling you, don't worry about anything below us. We are giving you the right answer. What will you do? And what will you give it back? What will you take from the children? And what will you do with it? And what will you give to the parent? Right? This is the my basic fundamental law, right? So I'm exactly trying to do that here. I'm just saying, hey, here's a set of denominations, 1, 2, 3, 4, etc. until 500. So where is the parent sitting? Like who? What is the question? What is the question we are trying to solve?
Minimum number of denominations.
Okay, give me minimum number of denominations for, let's say, $2,445. Okay, so who is asking? Here or here?
But the total amount is not a part of that denomination array, so I'm getting confused. Like, it's not on either end. 2445 is not in that list because it's not a denomination, it's a total amount.
Fair, but let's say you are going greedy, right? Where will
greedy
you?
Then from the right side will.
Okay, so what I'm trying to say here is, when we were just getting into this line of me, my. So you should. This is a very interesting part. Let's say you are the person who is sitting at the $20 note, $20 bill. Okay, and all your children before you told you that, hey, here is the minimum number of ways till them. Like they're not even saying what number, what end goal is, or what all that. Till them, this is the minimum number of ways. Let's say, okay, hey, there are the minimum number of ways is 3 ways. We can arrive at the number just before you. Now, what will you do? So remember, you take from children, you do something, and you give it to the parents.
So if I know the minimum I didn't understand when you said that the children, like 1, 2, 3, 4, are giving me one less than what?
So
Like that entire
I'm just
statement, can you
trying to say
repeat?
the same thing which I'm saying is, just in Fibonacci, you are sitting here, and the children before you are giving you something, you take that stuff, do something with it, and then give it to your parent, right? I just want you to say, now that we are at the second step of this, which is here, we are at me, my. I'm trying to formulate a me, my logic here. What will you do?
Okay.
So let's say you're sitting at.
Yeah. Let's say you're sitting at after 4.
20. So let's say you're
20.
20, right? So I can even write this like, let's say this way. 20 is sitting here. And we are calculating, like there is a bunch of these different ways possible. Minimum number of combinations. So it's probably could be like, until here it's 1, 1, 1, 1, 1. Oh, you cannot reuse. So it's like 1 plus 2 plus 3 plus 4. So there's so many combinations that can happen before you, assuming you can,
Yes.
yeah, right?
Oh, okay.
Right? You could just do 1 + 1 + 1. Let's say we repeat. So there is always possible 2 + 2 + 2, and you can go all the way to 4295. But
Okay.
some of all these possible ways, your children
Basically,
is saying, I will give you X, which is the minimum number of ways you can, we have to, so don't worry about me. You decide what you want to do. So what
So
will you decide?
20 will basically take the minimum of what its children has to offer.
Okay, and
it will
give to the parent.
add itself if the amount is less than the X plus 20. I mean, not X, that is the number of ways. Basically, it will see if I can still add myself to the total amount. If there is amount remaining, which is greater than 20, then it will add itself and do +1 because we are using one more coin and give that X plus 1 to the parent.
Okay, fair. So you're saying, let's say till here, till 20, something was built up and the number was 55, right? And there is number of ways of getting there. Your children are saying is one way, right? And then you will say, I'll add 20 and give 75, 55 + 25 to the parent who is asking me to build 2, 4, 4, 5. And you're saying you might have multiple 20s, 5 times 20s, But my question then is, who told you the path through 20 is the best path?
Yeah, no one told me.
Yeah, so if you have 1, 2, 3, 5, 10, 20. So let's say this most ideal path was this, skipped 4, went to 10, skip here. Now here, what are your choices? You as the owner of 20, what are your choices? Remember, you don't know whether including yourself or excluding yourself is a healthy thing to do. It's going to
So, okay, so then I can probably provide two options. One is including me and one is excluding me.
That's it. So that's all you need to worry about. Like DP, you should never try to open it if you remember, like include, exclude. So which is why we are re-insisting, like don't think what your child is giving you. Focus more on what I will do with it. So all your choice as the owner of 20 is either you include yourself or you exclude yourself. And you can say, okay, so if I include dear parent, here is the new number. Like let's say X plus 1, I'm including myself only 1. If not, here is a new number. The next guy figure out what I should do. Right? So that's all you need to know. That's all. You just answered the whole recursive problem there. Let's see what did I mean by that, right? So let's say, now let's rewrite the function signature again. So which is public static int. What is the min ways? Min ways of what do we have? Int total and int denominations. Okay. And of which, now the first thing we write is, where did we come here? Me, my. Okay, let's write the me, my logic. If I tell you, you are standing at 20, what are your two options? Just in English, nothing else. What two things will you do as the owner of 20?
First thing, I will not include myself. I will say I'm not gonna participate in the solution, and
okay, that's all I'm saying. Okay, you pass it back to the parent. That's okay. Don't worry about it. The only two options is exclude and include. Okay, that's it. Don't worry about anything else. So assume Now, assume that you're done. You're done with this step. Okay, don't worry about opening it up ever. Then what will be your exit or base condition?
You mean both of them? Base condition, what is the base condition and what is the exit condition?
Exit condition, like if we are writing as recursively, no? So how will you stop?
I will stop when the total is, we have achieved the total amount. Or if you're decrementing total, if let's say total becomes 0.
Okay, 1 second. Color change again. Color bigger pencil. No. So you're saying if they Windows color on
What?
just switching languages. I don't know which language I will swear next. It's a mixture of so many languages in my head. Okay, so you're saying, let's say again, if okay, finally, if let's say total you're decrementing, right? If total equals to 0, and let's assume total was 2445 when it came in. If total equal to 0, you just want to break out. Is that right? Break out or do whatever. Your target is achieved, right?
I mean, I was thinking we will return the minimum number of coins we have had, but I don't know currently
Okay,
how.
so what will you
Because
do?
it's not a part.
Sure, what do you want to return? You reached your goal. So what will be the number you want to return?
Basically, we don't have it in our definition function signature, but basically we will return the minimum number of coins. But if we are using something like DP, we would not return no.
You're opening the problem up.
Yeah, so I'm confused.
Go back to Fibonacci. Go back to Fibonacci. Fibonacci was, let's say, public static. This one was what Fibonacci was the number, right? So int fib int n. So you're probably asking the fourth Fibonacci number. All you do is take something from your child. So your first child is like child 1 plus child 2. And as you, as the owner of this person, all you do is return child 1, child 2. And you said, when do I stop? If n is equal to something, right? Here, what was the n value? N is the 4, the number 4, the index. What is the fourth value, fifth value? So when do you stop?
When you have reached 0.
0. Okay, n is equal to 0. Okay, what will you return? You need the backflow to stop somewhere, na? So if you remember, when we were writing the cache, we hard-coded 2 values. Which was it?
And yeah, 0 and 1. We hard-code that.
Okay, so when in 0, return 0. And if n is equal to 1, return 1. Okay, those are the 2 foundations on which we are standing, because we need 2 children. If it was only 1 children we were using, we would need only 1 exit condition. Now use the same logic here and say, stop worrying about DP and the full number and all those stuff. Here, we are telling you that by the time you reached this guy, and total is reached, what will you do? Total, we started decreasing when 2445 became 2335, something, and I'm telling you it reached the end. Now it's 0. So how many ways do you have at 0?
0.
That's it. That's all you need to think about. Okay.
Oh, right. Yes.
Right. That's it. That's what I'm saying. Don't think. Just think at the very surface level.
Yeah.
If tells you total ho gaya to ho gaya. Here take 0. I don't have ways back out. Okay.
Right.
Now we'll come back to that. There are some more things we'll have to add there. But let's go back to the exclude and include. So let's see, where are we? We are at the exit and base condition. So in fact, remember, your goal is to keep moving forward. Don't get stuck in anything. If you're getting stuck, you're already doing it wrong. Take a break, go around and come back. So now we are at the stage.
Right, because whatever you just mentioned, I think I really struggle with that. Like how whatever, because it's very simple. Like if total is zero, for example, if someone gives you, okay, I have, that's the question. N is equal to zero. What will you return? You will return zero, right? Because there is no way of making. So I don't know how I missed it, but yeah, good
Okay, so you
that
must
you made
remember
me.
in all the returns problems we have seen in recursion, almost always it's return 0, or maximum it is return 1, or sometimes you, in Python you just do a blind return when you have void.
Mm-hmm.
Almost always the 1 or 3 will be your answer. Okay.
Right. I was complicating it unnecessarily. I was thinking, okay, now we have reached our total. We need to return the answer. What is our answer? Where is the answer stored?
That's the mistake we do in DP and recursion. Don't open it up. Just follow the step systematically. Okay. So let's say you have the value, you have y. Okay, y is the number of ways if you exclude yourself. X is the number of ways if you include yourself. Okay, so let me go back to the example here. You are the one standing at 20, and there are so many of these combinations ways coming up here. So there is one way is include 5, not include 5. Everything has come and stopped there. Right, and there's this number which is probably just has only 4 and directly 4, using 4 it has come there. And somebody is telling you, out of all the possible things, there were around like there were one way here, one way there, one way here. This, I'll give you a number like x is equal to 8. You don't even need to know what that number is. And that's when I asked you, what will you do? And you said you will either include or exclude. So I am saying, let's say from two options here, right? Wrong color. Include or exclude. So if you include yourself, what will be the value? That number.
Total. What will be the value of the total left?
Yes, I'm saying, so if I give you two numbers, right? So I'm going to tell you like, hey.
I can't see this where you're writing.
Where did I do this time?
Like when you were saying 8 and everything, you were writing something.
Yeah,
I couldn't see
that's
that.
because I used the wrong color. Okay, so I'm just saying.
Okay.
Just say, okay. So did you see this part where we were doing 1, 2, 3, 4 combinations, and there is an X
yes
here, and you as the
owner.
No,
this I couldn't see. Yeah.
The owner of 20, you have options. Let's say if you include yourself, somebody tells you that the number becomes the number of ways is 42. But if you exclude yourself, the number of ways is only 40. So what is your job? So I'm telling you this answer. You're standing
40 is the number of coin or total value?
No. In this question, don't worry about the coin.
Okay.
Number of ways. This is, remember the stairs also, in the stairs problem also, this is something which confused us big time. Right? Even though they ask you the total count, what you really answering is the minimum number of ways. Okay. So let's say somebody told you, you have 2 ways. 2 ways through you or without you. If we took the path through you, then the total number of ways is 42. If we ignored you, the total number of ways is 40. And your parent is asking, give me minimum number of ways. So what will you give back?
40, minimum of both of them.
Perfect. That's all I'm saying. So you only have to return minimum of x comma y. You don't even have to think what x or y of any of those things. Your job is, they gave you 2 numbers, and me as the owner, if I am, all I have to do is send it, pick the lowest one out of these. Okay. And by the way, remember, when you're in this thing, when you are including yourself, your count will increase by 1. Remember, we are including yourself, right? So somebody told you, okay, let's say y's value is 41 and x's value is 39. So what you will be returning is minimum of 39 plus 1 because you're including yourself, comma, this number 41 exactly because you're not including yourself. Okay, so which is minimum of 40, comma 41. Okay. I don't see a good response. Still confused by the minimum number of ways, is it?
No, so we return minimum number of 39 plus 1, which was we include ourselves. And yeah, if we include ourselves, the number of coin increases.
Number of ways increases. If you don't include yourself, you don't know what the next guy is going to do. So all your job is whatever you got, pass it as it is. And between both of these, you need a minimum because the question is minimum.
Mm-hmm.
Okay. Let me put it this way. So we had denominations 1, 2, 3, 4, 5, etc. Let's say we had 500, right? So, and there was, before that, this was 200 and 100. So let's say the number given to you was 1,500, right?
Mm-hmm.
So somehow the calculation came till here and told you that, okay, the minimum number of ways to get here was 8.
Mm-hmm.
What are the two options you can give to your parent?
Mm-hmm. So one would be 500 will say, I will not include myself in the final solution. I am just gonna pass on 8 as is. So 8 is the number of ways for a total amount, which will be probably same. Okay, I don't have to think that far. Okay.
Don't
And
think.
then the
Yeah.
yeah.
Okay. So
And
just
then the other option is if I include myself in the solution, I'm gonna add 1 in the number of ways you can achieve the solution.
correct. That's it. So now don't even think about anything else multiple times, all those things. So what we are
Yeah,
doing,
that's what my brain is thinking, and I'm like stopping
this
it to
is what,
think like
this
that.
is what our education system has screwed up. But recursion is an extremely top-down approach. You have to trust the system blindly. Okay. So as we have seen so far, if you follow those 4 steps of my exit base condition parting gift, you yourself will solve the problem without realizing it. So it's like, don't open and become the logical person. I can even say, don't become the masculine energy, let the female energy and intuition drive. It's men who usually like divide and say, okay, I need to see the entire logic. Anyway, beyond the racist comments, okay, now so we know we have children, okay? And this was our parting gift. Okay, so parting gift is usually we want to hand over something to our children. Okay, so what is our first variable? First variable is total. Okay, total. What you need to fill up two variables here. If you are excluding yourself, what will let's say the incoming value was total or 2, 4, 4, 5, right? Whatever, total. What will you do to it?
You will not do anything. We'll just pass it on.
Perfect. So you'll pass it on total. And in fact, we don't want to use the entire list. While in recursion, what we forgot is what we want to pass is actually int I, or at least with or without that, we can also pass int bracket denominations, but or keep it global. But I is more important because we have to keep track of where we are. Now, so you are at 20 and you're saying, I have two options, include myself or don't include myself. Okay. So then you're opening it up and saying, if I'm excluding myself, of course, I don't have to do anything to the total. And all I have to do is hand it over to my child, which is I plus 1. Whichever way you are going, you can start I from 0, go up, or if you're starting I from here, you can go down. Right? So
can you repeat this part?
Yeah. So I is the index. So now the question is, the important question is, okay, let's see, are we building it up bottom up or top down? And multiple ways of reaching it, because remember when we started with greedy, we said, okay, greedy is obviously top down. We'll start from here. We'll do 500, 500, 500 and maximize it until we get 2, 4, 4, 5. Okay. But let's say I'm building it up bottom up and my index is starting here, 0, 1, 2, 3, etc. Each of these points, so we are adding up, right? We might do like 1 times, 2, let's, this is why I want to start it with no repetition, yes repetition, right? No repetition, yes repetition. So let's start with the no repetition case. No repetition case, may you come to 1. What are your 2 choices?
You take one or you don't take one.
Perfect. So you have 2 choices, take one or don't take one. Now you come to 2. What are your 2 choices?
Take 2 and don't take 2.
Perfect. So this is how this is branching out. These are your overlapping sub problems which you're trying to solve. Okay. The only difference is when that was no repetition. If I bring in yes repetition, only difference is you might decide your choices becomes higher, which is, oh, I will include 1, 1, 1, 1, 1. I might want to do 1 plus 1 plus 1 all the way up to 2, 4, 4, 5. And if you start thinking about it, it'll fuck your brain up big time. Okay.
Yeah, that's what is happening.
I know exactly, which is why I'm telling you, let's think about simple step first. Okay, forget repetition for now. Let's think very simple thing, which is you are sitting here in the middle. Let's say your index 0, 1, 2, 3, 4, and 5. You are at index 5. Your name is 20. Your only job is don't look behind, don't look here. They are telling you, so we have to pass to my children something, and in this case, let's call this children and this parent, right? And all your job is minimum number of ways is just fill this up blindly. Okay. So don't even think, just fill this up blindly. For example, your third value, you can see that is going to be same, which are integer of denominations is going to stay as it is because that's the global value. But this I, you have to let the problem pass through you or not pass through you. So I'm asking a simple question. What will these things change as? What will the total, what will the I, and what will the 10 denomination? Denomination won't change. What will the total be if you decide you're not including yourself?
Total.
Correct. But you want to hand it over to the next person in line.
Right. Move on to the next denomination, right?
Next, no, you're just handing it over to the denomination 6, saying, okay, you do your problem. It's not my problem anymore. Okay. So now let's come back to the same thing, which is, if let's say you are including yourself, what will the values be?
Total minus denomination at I.
Total minus denomination at I. So which is correct. You're trying to reduce the number. Basically, you started with 2, 4, 4, 5 here. And what you're doing is you maybe included 1, did not include 1. If you are including 1, you say 2, 4, 4, 4. Then you can say you're including 2, it becomes 2, 4, 4, 2, etc., etc. Right? So that's why there's infinite amount of combination, which will completely mess your brain up if you start thinking it that way. All I'm saying is do top down, fill up these numbers. What will your I value be now?
I plus 1.
Okay. So we are assuming there is no repetition, okay, because you don't have a choice. You have to give it to your child or the person next in line. So in this case, the person next in line is 100, right? Okay. And that's it. Denomination remains the same. Den remains same. Okay. So what have we done so far? What we have done is we just asked the question, if I was the person sitting at 20, what options do I have? You said options is either I include myself or I exclude myself. If I'm excluding, let me rewrite this number. Okay, total, I won't touch it. Total remains as it is. Oh, I have to hand over to the person next in line. I'll do I plus 1, and this guy never changes. Include, okay, then we realize that since I'm including myself, I should reduce myself from the total value, right, to tell others that, okay, total is getting changed. Then you said, okay, I plus 1, I have to hand it to the next person and done. The truth is, despite you wondering about all these things and opening it up and trying to solve all these problems, the truth is you're done. That is the beauty of recursion, right? You're done. This is the answer we're looking for. That's it. There are some bells and whistles we'll get to in a second, but that's it. We're done. So knowingly or unknowingly, by answering the question, what will you do as a person owning 20? You actually have figured out the answer to recursion. Because your job is, as 20 is, as the person sitting at 20, your job is your children saying, hey, here are 4 ways, here are 5 ways. I don't care. My job is to say, do I include myself or do I not include myself? Remember, same Fibonacci thing. What will I do as a parent? Here, as a parent, my job was combine A, combine B, send. Let me even remind you this one. So remember, we had a tree problem, and there was a tree like this: 1, 2, 3, 4, 5, 6. Clearly, I'm not winning the award this year for the best handwriting. Okay. So let's say you are 3, and you are sitting at the owner of 3, and your left child is saying, my height is 1, and your right child is saying, my height is 3. And your goal is find max height. What will you do as a 3?
Take the max of what my children.
Exactly. LCH, RCH. That's all you need to worry about. Don't worry about what they were doing. Assume they did their job. And this is the big thing which we have been trying to sell, this idea that don't worry about what they're doing. Assume they did. Assume they told you everything correctly. What will you do? Like, you see, you're not even looking at the total number of ways. You're only looking at the total value. The number of ways and all is not your problem. It has to organically evolve out of the answer.
Okay.
You see, if you had gone thinking n, it would have become a mess, because you start with 2, include 1, include 2 multiple times. Okay, now let's come to the multiple times problem. Okay, so this is solution for just including yourself 1. Either you can include or not include, right? Now, let me start with this question. So you said our exit condition is when we exactly reach 2, 4, 4, 5, right? So let me ask this question. I start with 2, 4, 4, 5, or even especially in this case, it's always important to think of smaller examples. Okay, I'm giving just 1, 2, and your goal is to make 3. Okay, how many ways can you make 3? Including repetition, it can be 1 plus 1 plus 1, first way. Second way is 2 plus 1. Okay, that's it, right? If you have repetitions, there's nothing more you can do here.
Yeah.
Okay, my question is, let's say I'm starting with 3 and go subtracting it, everything I include. So remember, we had yes repetition, no repetition. Okay, so in the note,
I think I'm confused about the question itself. It's number of ways or number of minimum number of denomination?
Minimum number of ways. But remember, even to get there, you are reducing this total minus D.
Minimum number of ways. So for this 3, answer is 2.
Correct.
Okay, what if like it's the third option is 1 plus 2 instead of 2? That does not matter.
That you probably won't encounter because you are climbing from one direction. No,
okay.
So there are 2 options. Either you repeat yourself, not repeat yourself. If you're not repeating yourself, you are at 3 and sorry, you're at the index 0, and you just, okay, I have 2 options at 1, which is to include myself or not include myself. So I come here, I have 2 options. And if I include myself, I will do 3 minus 1, for the total. Total is 3 minus 1. Index is I plus 1 because I'm at 0. I'm moving to the next guy, and your denomination remains same, right? That's equal to global. If you're excluding yourself, you will say 3. I'm not going to subtract anything. I plus 1 denomination. Okay, this is what we wrote so far. All I'm doing is to take a very simple example of 3. So far, so clear? Like every time you move, you reduce if you're including, don't reduce if you're not including. Clear? Okay. Now we are done with this part. Now comes the interesting part, right? Let's say you are again at I is equal to 0 and you're starting with 1. You first time you decided you will include yourself. Okay, so you're at 1, include, exclude. All right. So first time, let's say you decided you're including yourself. So how much will be the new value?
2.
2. What is I plus 1? What is the index? Sorry,
Index is 1.
so let's say so I was at 0. Okay, I was 0. At 0, the number you had and with you was
1.
1. Now you are saying I'm including it, but remember you can include yourself multiple times. So what will your index be?
I.
Same thing, right?
Mhm.
Okay, so your index is I, and my stupid pen has stopped working. Why would you do that? No connection. Edge case. Okay, so then second time you can be 3. Sorry, your incoming value is 2. You'll do 2 minus 1. Yeah, so then your outgoing value will be total is 1, and you can choose. You will try to include yourself, right? I, and then. So my question is, in this case, it's fine because you started with 3, right? You input total value as 3. You after index was 0, the value was 1. So what you did was you passed on 3 minus 1 is equal to 2. Second time total was 2. Your value because index was exactly same, so you're staying there. 3 minus 2, index 0. Just that in this case, it will be 2 minus 1 is equal to 1. Okay, now your incoming total is 1, and you're saying, no, I'm still going to use this. Okay, index is 0. And now it's 1 minus 1, that's equal to 0. And that's perfectly works with our exit condition because I'm saying if total is 0, finish everything, move on. You know? But think about this. If instead of 1, your denomination that was given was 2 and 3, and your still goal is 3. And if 2 decides, the owner of 2 decides to do the same thing, which is I will keep repeating myself. So the incoming value is 3. The initial value index is 0. Value is 2. And he says, okay, 3 minus 2, that's equal to 1. Again, he says, okay, I'll include myself again. So 1 is incoming. My value is 2. My index is 0. I'll do 1 minus 2 is equal to minus 1. Now, you see what happened, right? Now, we hit minus 1. It is telling us there is no way out of here. If you take that route of including yourself, there is no way out of here. And that is an exit condition in itself.
Yes, if the total amount is less than 0.
Less than 0. Okay, so far we have only captured int exactly equal to 0, but that is our positive test case. But there is a next negative test case also, which is what I'm saying is there's a chance that something will happen. It can be less than 0. Now let's think about what we want to return there. Okay, so here there are 2 cases. Even in here, if total equals to 0, the first one you said is correct, return 0. If total less than 0, what will you return? Remember, these are all number of ways. You want to return something which will just be percolated all the way back up to the parent.
Why can't we return 0?
Okay, so let's say we will return 0 in both cases. Is that right?
Yes.
Yeah, but there is a problem there, right? The problem is when you're returning 0, let's say you are the person sitting here, you're doing yourself multiple times, and then you're saying, hey, yeah, I found the answer. You come through me, but just before I hit minus 1, I'm going to tell you 0 is my return case. So I
Yeah.
used one, I used another 2. The truth is there is no way through you.
Understood. Yeah. We need to stop.
We need to stop and
Things.
return a red flag
Yeah.
to tell us basically that don't count this path.
Oh,
If
we
you
return a maximum value.
perfect. Okay, so you should return a max, what is it, int dot sys dot max size, whatever,
Floating.
sys dot max, or whatever you want to write return, right? And why are you doing that? Because when your parent is looking for the min, we want your parent to skip that guy because there's nothing that can be bigger than sys dot max size. Okay, so that is the only change to the if condition that you have to do. If there is yes repetition. See how simple it is. We never opened up and I mean, this we shouldn't have done, right? Because I'm just showing you an example. This would have come in our dry run kind of thing. But all I was saying was, all you have to do is if I have to include multiple times, what can screw up? Something can screw up is, oh, I might hit -1. Okay.
Right.
Now, there's one more exit condition that might happen. What is it?
If I exceeds the length of D.
Perfect. So if total less than or equal to 0, or your I index value is greater than length of DEN. Length of ring 3 is greater than
equal to greater than or equal to.
not equal to. Still 3 are allowed. No, 0, 1, 2, 3. Your length is always fucks me. If length is 3, you should be less. If I is greater than or equal to 3, you should exit. Correct. Okay. So those are the exit conditions we need to change here. And there is one. Okay, so let's see. Let's go back to our original this thing. Okay. What we were doing was we were paraphrasing. We finished all these. We have a decent code. Let's do a dry run. I'm going to have to erase this stuff. Okay. This is bad. This is bad. Okay. So let's see. Let's start with the dry run here. Use a different color. Okay. So when you come in, let's say we are sticking to the original story of we have 3 as a goal, and you are only given denominations of 1 and 2. So you start with 3. Your I value is 0 because you are starting here. The first, your I value, index value is 0, number 1, and your denomination is giving you the same list. You come here, you check if total is 0, no. If total less than 0, no. Let's return, what is that thing called? Sys dot max size. Very nice. Did it get the same color? God knows. Okay, anyway, so this is not no. So now you are deciding, do I want to include myself or do I want to exclude myself? Okay, so you decided you're excluding yourself. So what does the total become? Total doesn't change. Total still remains exactly the same, which is, what is the value? 3. I plus 1, its value becomes 1. Initially, it was 0. And this remains as it is. So we come back here again as a recursive thing, comes here, and the new index is 1, and this remains same. And new index is coming here and saying, okay, I'm at a new index, and 2 also is saying I'm going to exclude myself. Okay, so fine, 2 can exclude itself again. So your total remains that. This index value becomes 2, and this remains as it is. So you come here, total remains same, index value is 2. This is the same list. But then you hit this condition of if your, well, that thingy. I erased that here. Very smart. Okay.
You wrote it. I don't know where it went.
No, I think I erased it. So which is or I is greater than or equal to len of 10. Okay, so in all these cases, we return 0. Okay, so the path is basically, we start with 3. If you never do that while coding, this is for your understanding, it will fuck you up big time if you think about it. Started at 3, I'm at 1. So my goal is I can either include 1, not include 1. Okay, so include 1, exclude 1. So then from here, you have choices of keep including 1, etc., etc. Then it branches off big time. Okay, so don't even open it up, but trust your system that if your I is less than 0, it'll backfire, it'll just stop. Okay, so the point is sitting here, finally, when you're the parent, you're asking, this path I took, which was exclude 1, that itself gave me like 12 ways out of it. Okay, now if I'm including 1, what will be my change? My difference will be same thing. The total you have to reduce. Like, let's say you're including 1 for, let's start from scratch again, which is just coming in with I know. Okay, let's do the dry run again from excluding part. Okay, so we're coming in dry run again. Your total is 3, int is 0. This list remains same. You come here, total 0, total less than 0. Nahi hai. Is the length I greater? No, it's not. So you come here, your total, you decided you're not including. Sorry, you are including yourself. So you skip that part. You come here. So 3 minus 1, we send to the next part, next level of the stack. Now, what will this change as? The
I
index.
plus 1? Yeah.
So I
1.
plus 1 means you are giving it to, you're giving control to 2. But you're not, right? You're standing there. You're saying, no, I want to keep doing myself. So what will the index be?
I.
When you're including yourself, your index should be I. So now your brain will wake up, oh, but there is a possibility next time I won't include, next time I don't include, I might include, and all that stuff. But the truth is, just trust the system. What will happen in reality is, let's say you are only using 3, it will become 3 minus 1, 2, 2 minus 1, 1, 1 minus 1, 0, and it will exit here. So like, don't even think about opening it up. But this is the main difference. Like, if you decided you're including yourself and multiple times, so the I value doesn't change. Okay. So this is all you need, basically. There's one more edge case. Let's go back here.
I have one question. Like, what if I include myself, but I only include myself once?
That's not your problem. As far as you are concerned, your job is limited to this moment in truth, this moment in time. Okay. Let's assume you are doing this 1, 1, 1, and there are 3 1s, and you are the person who is manning this guy. You don't care if the next guy includes himself or excludes himself. It's a it's almost like we were saying non-repetitive. At the non-repetitive time, only difference is you were 1, 2, 3, 4, 5, and you are saying, I made a decision to include myself, exclude myself. I don't give 2 fucks what the next guy is going to do. So what we are writing here is only you. Your choice is either you include yourself or you exclude yourself, and change the numbers based on that.
Okay.
I know this will take a little time. You should like try this out yourself without any help. Just take the question because you have to like, and if you really want to open up, you open like 3, 2, 1 example. That itself will mess you up big time. But my point is, if you do top down, that's it. So let's see. Let me share my screen again, not the other one. So, share, stop share. See if I start sharing this, will it automatically? That's perfect. Continue. Desktop. Okay, can you see a Chrome window?
Yes.
Yeah. Let's try. Okay, take it. The same question, and this is the smallest number of coins you need to add up. Do I log? Perfect. So let's start as it is. Let's try running the same problem, right? 125 amounting to 11. Let's say if they're allowing us to return the fewest number of coins that you need to make a money. If that amount is money cannot be made, return -1. Okay. You are given an integer array coins representing coins and given an integer amount representing total amount of money. You may assume you have infinite number of each coin. Yes. So you can. Is this, even though I'm confused why it is not giving the function signature? There
Yeah, okay.
you know, okay, so this is my answer. I won't show you that. And that alarm was not for you. Alarm was not for you. Coin change. Dash coin change. No. Okay. So let's start this, right? So let's go back, also bring the other thing which we had next, which she just wrote down. So let's call it, go back to,
Are we coding it up?
yeah, do you have time for that?
I have time. I'm just thinking about Calista.
That's fine. It's very hot. We are not going out until sunset.
Okay, cool.
We're not
Okay.
going sunset, and she better know that. That a big time. To the left of the screen. There you go. Again, left of the screen. No, left of the screen. Not actually done. Okay. Just trying to get to the answer we wrote down today, which is public static int min ways, public static int min ways. Okay, there you go. Min ways total. Side by side is better. Okay, public static int min ways. So let's see if I open they should have given me a structure. How do I get the structure? Go back to Sky and Sky and the structure they gave.
Refresh it. No.
Does it happen? Refresh. I think just numbers.
No, refresh. No, it's on the right side.
Got it. It's on the right side. Got it. So they are giving you the coins, the list of the amount, and your goal is to return the minimum values. Okay. So let's bring up the left-hand side of our code. Okay. So let's say we start with public static min ways, but in our code, total is there. It's called amount. Coins of list is also that denomination, but what we don't have is an iterator going through each of the coins.
Right.
Okay, how can we do? They are only given you this function. What can we do for it?
So we can create a helper function and write the arguments that we need. So we will, do that.
Okay.
Self,
so
total.
Same thing.
Let's stick with the same variable names. No, it will be easier.
Okay, so let's call it total int I location. Okay, int I is your index. We'll have to go change there and call it. This one is 10. This one.
No, we can call when we call min ways, then we can pass on those values. We don't have to do this here.
You're okay with the word coins and amount there?
Yeah, because we will call min ways.
Okay. Okay, so let's only focus on min ways for now. So it's right? So at the end, we have to return a -1, but let's not worry about that. So our code was, we wrote the function signature, and we asked ourselves, okay, what are the options? Options are I either exclude myself or I include myself. Okay. And then we said, okay, we'll fill it up when we get there. Our exit condition is if total is less than or equal to 0, that will happen. In that case, there are two things that can happen. If total equal to 0, we just say return 0. Else, it should be total. Else, you return sys.max size. Probably have to do a -1.
So in Python, you do float bracket in double quotes, write -inf.
Say that again. Return what?
Float,
Uh,
right? Float, bracket, double quotes. Inside that minus INF.
but I don't want minus. I want the plus INF, right?
Oh,
Can I do-
minimum, yeah. Plus infinity. Yes, yes,
Yeah.
sorry.
Okay, good. So now that is one case, or we discuss another case, right? What is the ending that might happen?
If I is greater than or equal to len of 10.
Greater than or equal to length of points, length of 10. Okay, length of 10. So this is your first, there must be something missing in bracket of if total or this. Okay, and you also want to check if my n is equal to 0, if total is less than or equal to 0, or my I is beyond this, okay. Then if you check if it is this case, if total was 0, return 0, else return float of infinity. Okay. So even if you run out of 10, then you will say float of infinity. Okay. So let's come back to our include exclude. So this is the, we are going to write the parting gift. Parting gift, let's call it y. So in our left hand side, you can see y of min ways of, let's simply copy paste for now, right? Min ways of starting May. Same thing for x will change in a second. X is this, and your goal is to return min of y comma x. So far, so good.
Okay. Yes.
Now, if you are including, let's say you're excluding yourself, what will your total value be?
I'm including myself, total minus den of I.
Exclude.
I'm excluding myself, then total remains the same.
Okay, and who will you hand it over to?
I plus 1.
Okay, perfect. So you're not including yourself. Uske baad what happens is none of your problem. If the first guy doesn't include himself, the second guy cannot include himself anyway. I mean, if one was repeating, the first guy at least has to repeat. Now in X, right? What will you do with the total? If you're including yourself, so total minus.
Minus den I.
Okay, and what will be the I value?
I will be same.
I'll be same because I say you can infinite number of coins. Don't even think about it. Just do I and trust the exit conditions. Okay. Return min of this.
Yeah, use in line number 9, like in Python, use self.minways and remove the self from the recursive calls, like line number 19.
Oh, you can do
self.minways. Yeah, and remove the self argument. Yeah.
This is what gets me all the time. Python should have officially learned. Okay. And actually, you're done. Like, only thing left is how do you call the helper function? So what do you want to do for the helper function?
You call return minways.
Let's look at the questions, okay? So we are given an integer array coins representing different denominations, integer amount, return the fewest number of coins, okay? If that amount of money cannot be made up by any combination, you have to return -1. So let's say you are some value out. The out is coming from your child. You're giving it something, not yet. What will you do for this?
Sorry, I was coding. Return the fewest number of points you need not make up. Yeah. Okay. So if we have reached I plus 1, like if our I is out of bounds, then instead of returning float infinity, we need to return something.
You're saying if the out value which came out of min ways, right, is float infinity.
No. Wait 1 second. Let
No?
me think. Return the fewest number of coins you need to make up that amount. If the amount of money cannot be made up, return the fewest number of coins that you need to make up that amount.
Which is telling you is out. You're only two choices. Out will have either an integer value, like in this example, if you give the coins 1, 2, 5 and the amount is 11, the output will be 3, or the output in our case is float infinity, we deliberately did that because adding -1 could have messed up this min value here, right? So which is why we picked the highest value. So you have only two options for out. Either you'll have an integer or you'll have a float of infinity.
If it is float, then what will we return? We don't have that result with us.
Huh, that's okay. That's why they're asking return -1.
No, I thought they want the nearest answer.
That amount of money cannot be made up by the given combinations, return -1.
Okay, this sentence is crazy. Okay, yeah. Got it.
Return the fewest number of coins. That is our actual problem, which is what out contains. There's a chance that it goes and hits. Remember, we were doing the minus karke, 3 minus 2, this one, 1 minus 2 minus 1. So we have written code for it to automatically send us this big value. And all we're checking, if it's a big value, question asks me to return -1, I'll do, or not, it is the same value. Okay.
Okay.
So now what else do we have to send inside? Let's see, you have coins, you have int. Your minways is, this is a signature for minways. So try to bring that both in the same.
To send amount 0 because I is 0 at first.
Self.minways, okay.
Yes.
First value is total. What is the total?
Amount.
Okay. What is
I,
value?
0.
I0, perfect.
Points.
Got it. Perfect. Okay. So let's read this again. So if you really want to stuff, what we have done in our systematic way is we paraphrased, we wrote core logic, we did dry run, we even thought of 1 or 2 edge cases or null case. Edge cases was this one. We coded it out and we are at the point of read it out completely. Okay, so let's start. Coin change is giving me self coins list of int and amount of int. Okay, out is equal self.minways, which means I'm calling my another function out so that I can trigger and bring in the I value self.minways of amount, 0, coin. Okay. If it can give only 2 values, it can be float maximum return out. Okay. Minways takes in total I and den, which is total I and denominations. If total is less than or equal to 0, or I is greater than or equal to length of 10. And if total, if we should probably hit that. I'm a little worried about this, which should be an explicit condition, but we'll see. Let's say if the total is equal to 0, then we know our job is done, just return 0. Else, return a very high value, else return float of infinity. The syntax is correct, right? Okay. Exclude and include sinch.min.ways with total of I plus 1. Self.minways total minus den of I. You change the total I den. Okay. Return min. So far, so good. Let's see. Wrong answer. What is the answer? Your output is 0. Expected is 3. Okay. So one thing which we haven't added is, let's say the number you're given is bigger than your biggest amount. Say, for example.
Yeah, but the test case 1 is not that, right?
1, 2, 5. Yeah, that's true. You're right. Let me check this. No,
Actually, I also wrote it side by side, and it's failing for me for the same test case. And
one second. Total is equal to total. If I greater than length of coins, or just want to make sure one thing. Okay, if separate this out. Okay, okay. Just want, like, if I is data equal to, so just return this guy. That's basically your out of options. Okay. Then another option is, first thing is check length. Total is less than 0 or total is 0. Okay, okay. What else do we? What else can we do? What are we returning? You're saying it's returning 0. Okay. And you're returning out. Return float of infinity. I have a very simple question. I know we should never do this. We should. I'm just wondering your thingy. What is called the float infinity? What is it returning? It's STD out. These are forward 0. Okay. So if my I is greater than or equal to length of coins, or if n is less, total value is less than 0, total is equal to 0, return 0 total, else return maximum. Okay. Y is equal to self dot min weight. In the first case, this is 125 self dot min weight of if you are including myself, please call this as exclude and include itself. Exclude. Yes. For my clarity of brain's sake, minimum of include. Okay, I know what happened.
What happened? I'm still confused.
You tell me. There's one thing we missed. So we are, let's go back here. So initially we were returning, if I'm including myself, X, the value I should be comparing with is X plus 1.
Value I should be?
Sending to my parent should be X plus 1. Because I'm including myself. That's right.
Oh.
Same thing if you want the exact numbers here, we were not doing X plus 1 because remember our goal is we are sending back minimum number of ways.
So you included something.
I'm including
so
something.
You need to do,
the number of ways was increased. And what you do with it is not my problem. In fact, it should be really here so that it doesn't confuse us. Okay, X comma Y. Now it will make sense because now it logically also makes sense. If I'm including myself, I'm going to ask my children, do whatever you want. But since I decided to include myself, I'm going to increase the count my children gives me. Okay. What else? Let's try this.
Wow, okay. Awesome.
Let's see. Submission might bring in a bunch of edge cases, which is, your I is less than N and all that crap. Write that meanwhile, which is my value. So if I have
I don't think I think you covered all the edge cases. It's just that TLE, it needs memoization.
I honestly haven't been able to cross this point, but let me just try one thing, which is if the value of coin is greater than, right? So if I'm saying if 10 of I is greater than N or Ni total. Total. I want my result to be, it's almost as good as I am excluding. Okay. Once. So basically there's no point including me. I'm not even letting you go into the next loop. All I'm saying is rest is just the value I'm getting exactly what I got from my children. I'm basically saying I'm excluding myself. So the total remains the same. I just hand over to my child. There's no point. So for example, if the amount was 3 and 5 was the first guy we are encountering, you cannot do anything with 5. So you just throw it away. Okay. So this is 32 out of 189 test case passed. Let's run this again. Accepted, submit. Yeah, same thing. I like to think about what is going on here. But interviews ke liye, this is enough. They are accepted, it's running all the cases, and you're not trying to win the competition. There might be some edge case we forgot. What is this? 405 time limit exceeded. Something is getting an infinite loop without breaking out. Funny enough, why would that not happen for other things? No? Anyway, that's an interesting challenge, but okay. Try this out yourself. Like, write it from memory. Like, only have this window open and try. First, write it from memory on pen and paper. Then write it here. And then see, at least try to pass the accepted test cases. Okay? And
I did.
Huh?
No, please tell me.
Also, give this a thought. Is this the same as the staircase problem? isn't it the same as
Okay.
include or exclude? Just give that a thought. Okay. I don't want you to answer that now. Lead code, stairs, climbing stairs. So the climbing stairs, it's almost same thing, because your choices are either you take that step or not take that step. Now, once you're thorough with this, try rewriting the stairs using that logic.
Okay.
So this is actually the golden thing which I was saying. DP, all you have to do is include or exclude. Eventually, if you know the trick, everything else is very simple. Everything comes to this particular thing. What do you want to do with that? Include or exclude.
I'm still blown away.
I
But
know.
like, how is this working? And and all the questions that I was thinking at first, I was thinking, okay, if n is divisible by that number, I will take out that much amount and send the rest of it. All those all the questions that, actually cloud my brain a lot. And whereas I should be thinking in this manner. And if I do, and if I write it, it will work. And it does work. I'm just like blown away.
So this is what I'm saying, which is the biggest trick. Like, people hear DP and they're like, "Gaya, mera interview gaya, baad mein." When you say DP, you should be really happy, because there's only exactly one way of doing it. Stairka is, do I include myself or not include myself? 2D grid was, do I add myself? What do I do with the thing I got from my children? Okay, I can either not add myself or decide based on that. That's it. And once you follow this systematically, like, do not think and open up. Even do not try to do a dry run with like a bigger number other than 3. See, even with 3, you saw how much number of options that can come up, and it can mess up your brain. But if you systematically trust the system and ask the questions, my question, now that is the most important thing there, which is, okay, I don't care about what others are doing, but if somebody tells me, like, my children told me 20, I'm sitting here, my children told me there are 8 ways to get here. I don't know how he got it. My job is either to include myself or not to include myself. Okay. And I have to make sure it is a minimum value, and I just return the minimum value. If you can get these 3 lines, you're done, basically. Everything else is bells and anyway, this is what I learned from my guru, and I was mind blown when he started with recursion and doing all this. And now it all makes sense. Everything is recursion. Sure, not the most optimized way. It's recursion is the best way to start. And then you will slowly build up the, without opening up the problem. Once you have the recursion solution, you are done.
Right. This is magic. Whatever I saw today.
I mean, next level, we'll add like data structure and all that. That's the easy part. You can look up all things, but those are all easy part. Even converting this easy part. एक बार तुम्हारा recursion एकदम मतलब पानी जैसे किसी भी रात को उठा के पूछेंगे, you can write a Fibonacci series. That's what I do when I come back after a week of break. First thing I do is I write one Fibonacci ka whole problem again, white paper pe. Then I write one of 3 problems, very basic problem, find the length of tree. Oh, then I remember all the recursion. Tab se you can just reuse it.
Right. Yeah, good.
Okay. Just give this a thought, and I'll see you tomorrow. Tomorrow 1 p.m. Yeah.
Yeah, sounds good.
Okay then. All right.